Alright guys, welcome back. Today we're going to do this real world trigonometry stuff. Okay, so basically, word problems. And when you see trigonometry, that means SOHCAHTOA. So for every problem, we're going to make a drawing, okay? It doesn't have to be beautiful. It just has to show me where everything's at. You got to write an equation. This is important. This is what a lot of you guys are forgetting. And finally, solve. You will need your calculator to do that and units of measure. So if it's in feet, I want 27 feet or whatever it might be. All right. So first one, Carrie places a 10-foot ladder against a wall. Okay. So we have the ground. We have the wall. Then we have the ladder. And the ladder itself is 10 feet. Okay. And then it tells us the ladder makes an angle of 65 degrees with the ground. So ladder, ground, the angle between them is 65 degrees. Okay. And they want to know how far up the wall. Well, if this is the wall, okay, they want to know this distance, so x. So out of SOHCAHTOA, we're looking for opposite, and we have the hypotenuse. So since it's SOHCAHTOA, opposite and hypotenuse are sine. So we're going to do sine of 65 degrees is equal to opposite over hypotenuse. Then from there, all you do is multiply by 10 to get x by itself. So 10 times the sine of 65 equals x. That just goes in your calculator. So 10 times the sine of 65 is 9.06. And we're talking about feet here. So that's how far up the wall it is. Okay? And remember, your hypotenuse should always be your longest. So if you got something longer than your hypotenuse, you did something wrong. All right. Number 2. A flagpole casts a shadow that's 15 feet long. All right, so you got a flag. Here's the ground. And if you think about it, the shadow can only be on the ground. You can't look up and see a shadow unless it's on something. So the shadow is on the ground. Okay, so that's 15. Okay. The angle of elevation of the sun is 40 degrees. Okay, so basically, if you're looking right here at the sun, and that is 40 degrees. And they want to know how tall the flagpole is. So this. So we have this angle. So this is the angle we're going to use as reference. And we have opposite and adjacent. So for SOHCAHTOA, the only one that works is tangent, opposite over adjacent. So we're going to do tangent of 40 degrees equals opposite over adjacent. And the solving steps are the same as for number 1. Multiply by 15, multiply by 15, and put that in your calculator. So 15 times the tangent this time of 40 degrees is 12.58. And we're going to go ahead and round that to 2 decimal points. So x equals 12.59 feet. That's how tall the flagpole is. Great. This one is probably the most difficult one on the page because it requires an extra step. Okay. So in Southern California, there's a 6-mile section of I-5 that increases 25 feet in elevation. Okay. And they want to know the angle of elevation. So if you think about it, here's what's happening. The road is going up. Okay. Elevation, okay. So if you think of elevation like an elevation of a mountain or from where you live, you know, it's just height from sea level. So it says it increases 2,500 feet. So that's here actually. Okay. And then the road, this part right here that's going up is the actual road. And it's 6 miles. The reason that this is hard is because this is in miles and this is in feet. So you're going to have to convert. Now you could look it up, or I could just tell you there's 5,280 feet in a mile. So if you multiply that, so 6 times 5280, that's 31,000, sorry, 680 feet. Okay. And they want to know the angle of elevation. Basically, how much is this going up? Okay. So we have opposite and hypotenuse. Okay. So that's SOHCAHTOA. Oops. It's hard to see. TOA. Okay. Opposite and hypotenuse. So it's going to be sine of, I don't know, okay, x is equal to opposite, 2,500, over hypotenuse, 3,168. And we have to find x. So this is the first time today that we have to use an inverse. So inverse of each side. Cancels out the sign here, and what you do to one side, you do to the other. Again, you just put that in your calculator. So inverse sine, so that's where you do second sine of 2,500 divided by 31,680. And you get x equals 4.5, and then we're going to round, so 3. And we're talking about an angle here, so it's in degrees. So that's the degrees. It should make sense to you that it's a small degree. If you think about it, the road shouldn't increase that much in a quick time, right? It should be a very small angle. All right, this one, we've got a hot air balloon, which is 100 feet above where it's planning to land. So you got your little hot air balloon. Not a great drawer. All right, so hot air balloon. And then here's the ground, and it's 100 feet in the air. Okay, and you know it's this one because it says straight above, okay? Directly above the ground. Okay, Sarah, we got Sarah over here in her car, which is the cutest car ever. Okay, she's driving that way. Okay, and the angle of elevation is 35 degrees. So this is 35 degrees. And we want to know how far Sarah is. Okay, so that's on the ground level, right? We want to know from where it will land. So from there to there. So this will be your x. Okay. So we have opposite and adjacent. So again, that's going to be tangent. So tangent of 35 is equal to x over, no, opposite over adjacent, 100 over x. All right, so this is the first time we've actually had the situation today where the x is on bottom. Okay. So you have a lot of options here on how you want to solve this, but the easiest one is if you have on the x on the bottom, you can just flip-flop these. So x is equal to 100 divided by the tangent of 35. And that just goes directly into your calculator. So you get 100 divided by the tangent of 35 degrees. And you get 142.81, and then we're talking about feet here. All right, this one's a little difficult because this is the first time we've talked about an angle of depression. Okay, think depression, sad, down. Okay, so we've got an airplane, okay, and it's flying along that way. Okay. And then we've got the airport. All right, so the angle of depression as the airplane comes down is 7 degrees. And the plane is 2,000 feet above the ground. Now there's a couple different ways you can do this. You can make this one here your triangle, which is probably intuitive, but that's actually not what I did. I did this. So this is 2,000 feet above the ground. Okay? and they want to know the distance from the plane to the airport. So the plane to the airport, that's got to be this. Okay. So the only problem here is it requires an extra step if you do it this way. If this is 7 degrees, okay, this is complementary. Okay, they both add up to 90. Also, if you think about parallel lines, this has to be 7. But anyways, this is 83 degrees. Okay, so if it's going down 7 degrees, okay, what's left over here is the other 90. So 90 minus 7 is 83. So that's the trickiest part of this one. Okay, so you have this angle now. You have the adjacent angle, and you need the hypotenuse. Okay, and so I believe that's the first time today we get to use cosine, because adjacent over hypotenuse. So cosine of 83 is equal to adjacent over hypotenuse. And you have the same situation with the x on the bottom, so you're allowed to just flip them. So x is equal to 2,000 divided by the cosine of 83. That just goes in your calculator. 2,000 over cosine of 83. And you get 16,411.0, we'll go with 2 because we're rounding, feet. Okay. Now this might seem like a big number, but that should make sense to you. Okay, it's 2,000 feet above the ground, and it's only gone down at 7 degrees. So this is a very, very small angle here, so it's going to take a really long time to get to that airport. All right, number 6, Michelle is 60 feet away from a building. So we got Michelle, we got a building, and she's 60 feet away. And she wants to know how tall it is. Okay, so we're going to go to the top of that building. And we said the angle of elevation is 41. Remember, elevation is angle up. Okay. So we want to know how tall the building is, so that's this right here. Okay. There's little windows and a door in the building. All right, so we have this angle. We're looking for opposite. We have adjacent. That is a job for tangent. So tangent of 41 is opposite over adjacent, which is 60. Multiply each side, multiply by each side. Okay, so x equals 60 times the tangent of 41. That goes in your calculator. 60 tangent of 41, and you get 52.16 feet. Last problem, and this one's kind of difficult because it actually has a typo in it. A ramp is used for loading equipment from a dock to a ship. The ramp is 10 feet long, and the ship is 6 feet higher. Should say right there. So add that, 6 feet higher than the dock. Okay. What is the angle of elevation? So we're looking for an angle here. So you don't need to draw a boat and a dock. Okay, but if you want to, you can. So let's say this is the dock out here. We've got a ramp going from the dock to our boat. And our ramp is 10 feet long. So it's actually the hypotenuse. Okay, and the ship is 6 feet higher than the dock. Okay, so I'm going to actually redraw this one out just because I don't like it there. Okay, so the ramp is 10 feet. This is 6. And they want to know the angle of elevation. I know it's the angle of elevation because it's how much it's going up, right? It's being elevated. Okay. So to do that, I have opposite and hypotenuse. So the only thing it could be with opposite and hypotenuse is sine. So sine of x equals 6 over 10. You can reduce that if you want. Your answer should come out the same regardless. 3 over 5. Okay. To get x by itself, inverse sine of each side. Okay, because the whole point of inverse sine is to cancel with sine. But what you do to one side, you do to the other. So sine inverse of 3/5. X is equal to, and then you just put it in your calculator, inverse sine of 3 over 5. which is 36.87 if you round to the second decimal point, degrees. Remember, we're looking for an angle, so it should be degrees. All right, so those are our real world trig problems, and make sure you have these correct and you understand them, and make sure you have your study guide done. Okay, that's due on Wednesday when you walk in, tomorrow if you're watching this today. Okay, and your test on this whole chapter is tomorrow. So let me know if you have any questions. Like and subscribe to my channel. Okay, thanks, bye.